Hey, hello, and welcome to today's system design session. That is design rate limiter. Okay. So whenever an interviewer asks us, right, to design something, so the first natural question is to understand what is that we want to design, right? So let's see what is rate limiter, right? So a rate limiter is nothing but to control the traffic, to control the traffic of incoming requests or data which comes into a system, which comes into the software system, right? So, for example, to throttle the number of events or number of requests coming in particular frequency, in particular time frequency. For example, Facebook, FB might allow just an example, just a rough example, 10 posts per second. Okay, it's just an example. FB or Instagram, right? Or Twitter allows 300 tweets per user per hour. Just an example, right? Or uh, generally, the banking systems allow 3 password attempts, right? Password attempts in a day, attempts in a day, right? Banking system allow, yeah, 3 password attempts in a day. Or what else can we have, right? Yeah, so Google Doc, right? Google Doc APIs, they also have rate limit. They generally allow let's say 200 read requests, right? 200 read requests per hour per user. Just an example again, per user. So this is nothing but controlling the traffic, right? The incoming traffic into the system. Now, why do we need rate limiter, right? What are the reasons, uh, primary reasons for limiting the incoming traffic or controlling the incoming traffic? So few reasons can be like the DDoS attacks, right? So there can be some malicious users who can misuse our system, who can generate a lot of requests, lot of read, write requests or post request, right? Continuous post request, which can overwhelm our system, which can take our system down. Okay, so there can be so much request that our system cannot control the traffic. So this is to avoid DDoS attack. Why we need rate limiting, right? To avoid DDoS attacks. Okay. Yeah, as I said, malicious users can misuse our system. Okay. Second can be like our infrastructure limitation, right? We can handle our infrastructure or our system currently can handle only this much request or these many requests, right? Or only certain amount of incoming traffic our system or our infrastructure can handle currently. So there as well, we may need rate limiting, right? Okay, so these are the primary reasons for to as to why we need rate limiting. Okay, so now let's see, right? Once we are done, once we know that what is rate limiting, what is we want to design, right? So the next step is to understand the functional and non-functional requirements. That is the requirements we need to understand. Okay, so what can be the functional requirement, right? We need to understand from the interviewer, right? What can be the functional requirement? So after understanding what is rate limiting, definitely the main functional requirement is to limit the number of requests, right? Our system, right, should be able to limit the number of requests, okay, within a particular time interval, right? For example, right, 15 request per second, right? So our system should only allow 15 requests within a second. Okay. Then, so this is the primary functional requirement, right? And what can be a few of the non-functional requirement, right? Our system should be highly available. Our system should be highly available, highly available to to limit the number of requests, right? To limit the number of requests at all time, right? So it should the downtime should be almost negligible, should be minimum, right? And our system should always be available to limit the requests, right? Or to do the rate limiting, okay? And the next can be, the next point can be, yeah, so it should do with minimum latency. Rate limiting should be with minimum latency, right? Rate limiting should be with minimum latency, okay? So our main user experience shouldn't be affected. This should be done with minimum latency, okay? So these are the requirements, right? Now once we get the requirement, right? So um, so let's first understand what are the few algorithms to limit for rate limiting, right? And then we'll design the system, okay? So what are the few algorithms, right? So right, so there are quite a few famous algorithms, right? So one of them is fixed window algorithm. Fixed window algorithm, okay? So what is a fixed window algorithm, right? So in fixed window algorithm we have fixed time windows, right? Fixed time windows. And within the fixed time windows, for example, if it is 4 o'clock, right? 4 o'clock. So, and let's say our system wants to or our system, right, limits like allows 5 requests per minute, right? Allow 5 requests per minute, right? So it is divided into fixed windows, right? So if it is 4, then 4, uh, uh, 4 o'clock, 4 hour and 1 minute, 4 hour and 2 minutes, right? So if it is, so within this 4 to 4 1, right? Within a minute, it will allow 5 requests only. Okay. In if okay, if in the first in this window there were 5 requests, so these were accepted, right? In the second window, if there were 7 requests, right? In the second window, if there are 7 requests, so right, so these the 7 requests, right? So the 2 requests, these are 2 additional requests, right? Which will be rejected basically because we allow only 5 requests in a minute. So right, so the minute is not done yet. The minute is not done yet. So that is why we rejected these 2 requests. Okay. So this is what is the advantage of this algorithm, right? What is the advantage of this algorithm? So the advantage or the pros is easy to implement. Easy to implement because it is a fixed size window. We just have to keep track, right? We just have to keep track. For example, yeah, we just have to keep track of the number of requests in a minute, right? Of the number of requests in a minute. Okay. And what can be the con? What can be the con? Cons can be, con is, now what is a con here? Let's see. Now this particular algorithm uh, accepts more requests at the edge of the time window. Okay, so the disadvantage here, the demerit here would be, uh, right, that is, let's see what will be the disadvantage, right? If you look at this window, right, now let's say this is 4 o'clock, right, and this is 30 second, right, 4 hour 30 second, this is 4 hour 1 minute, and here 4 hour 1 minute and 30 seconds. So in this window, in this 30-second window, right? So there were 5 requests had come. Okay. And it was accepted. Definitely, naturally, it was accepted because within a minute, there were 5 requests, right? Within the last 30 seconds, only there were 5 requests, right? Before 30 seconds, there were no requests. And and when it is 4 hour and 1 minute, the time is reset, the time window is reset, right? And within the first 30 seconds there were additional 5 requests, right? And the requests were within first 30 seconds only, right? So these were, so if you see, right, so definitely these 5 requests were also accepted, okay, because it was well within the range, right? But if you see, right, at the edge, if you see, if you consider this, right, 4 hour 30 seconds to 4 hour 1 minute 30 seconds, so this is 1 minute window, right? This is 1 minute window. But here in this, if you see in this 1 minute window, there were 10 requests which were accepted. If you see, there were 10 requests which were accepted, right? So which is more than the allowed, which is more than the allowed limit, right? What is the limit? 5 requests per minute. But here, if you see at the edge of the window, at the edge of the time window, we are allowing more requests. So more requests, we are not adhering to the rule, right? So this is more requests allowed at the edge of the at the edge of the time window, right? So this is the con, right? So yes, so generally will so this fixed time window, as we see, it is easy to implement. It is pretty easy. The timeline is divided into fixed window size, right? And let's say generally, what would be the storage needed, right? What would be storage needed? If we are limiting per user, right? So we can have a map like structure, right? Wherein user would be the key, and um what would be the value? The value would be the timestamp. That is the start of the time, right? And timestamp, for example, the timestamp epoch time is something like the 760, right? Which is nothing but it is 4 o'clock, and number of requests allowed, right? Number of requests allowed, for example, till now at the 4 or 30th, right? Only 3 requests or only 3 requests. So yeah, it will be the count of the request which are accepted by the system, right? So generally, we'll discuss this in detail, right? But user and the value would be the structure of the timestamp and the count of the requests which were allowed, right? Okay. So we'll discuss this into detail. So this is fixed time, fixed window algorithm. The con is more requests allowed at the edge of the time window. Okay. So let's move on to the next algorithm. Okay, that is a sliding window algorithm. Sliding window algorithm. Algo. Sliding window algo. So this particular sliding window algorithm, it overcomes the disadvantage of the con of the first one, right? So let's see how it works. Let's see how it works. Basically, this algorithm works in the sliding window fashion, right? It does not have the fixed window as per the previous algorithm. It works according to the sliding window algorithm, right? So let's say so So how this works, right? How this works? So what it will do is first step. Let's say if our system allows 5 requests per minute. So what it will do, this algorithm, right? It will first remove. Uh, yeah. So first let me tell you, if we are limiting according to the user, right? According to the user. So what, for example, we are storing in this algorithm, the key will be user, right? User, and the value would be a sorted set, okay, containing the timestamp, contain a timestamp. For example, if we are allowing, let's say, three requests per minute, okay, and if it was the user was Adam, for example, right? Adam, right? So the value would be what? The value would be the number of the value would be the timestamps, okay, representing the requests which had come at that particular time, okay. So for example, if it was one request had come at 4 o'clock, right? So we will store the corresponding timestamp, right? 760, right? The next request had come at 10 second, 4 o'clock and 10 second. So we had accordingly, right? We had stored this one, right? The corresponding timestamp, and this will be in the sorted order, right? The next one had come at 50 second, right? 4 o'clock, 50 seconds. So we will store accordingly, right? 9:50, for example, right? So in this way, we are going to store. Okay. So what we'll do is, this is the structure, right? This is a structure map, maybe, right? Which we are going to store, right? So what will be the steps, right? The first step would be that whatever is a current time minus um, minus the last time, uh, current time. Okay, so the first step for this algorithm would be, let's say we are accepting three requests, right? Three requests per minute, right? Per minute. So the first step would be, whatever times we have, the older times, we are going to delete them, right? Current time minus 1 minute. Okay, current time minus 1 minute. So the older timestamp than these one, right, will be removed for this particular user, right? And then we'll see how many how many timestamps are remaining now. How many timestamps are remaining? If it is more than three, then reject the request. Reject the new request, right? New request. Okay. If it is less than three, then add the new timestamp and allow the request, right? Add the new timestamp and allow the request. For example, right? For example, uh, let's say now this, okay, let's say now three requests, right? Within this time frame, three requests were accepted for Adam, right? Now at, uh, for example, now at 4 o'clock, 1 minute and 20 seconds, right? A new request had come. So what we'll do according to this first step, right? Current time minus 1 minute, right? So the current time is 4:01:20. So within this, from 40, right? Uh, uh, so anything which is older than. So what will be the current time minus 1 minute window? Current time minus 1 minute window will be what? If the new request had come at 01:20, right? And minus 1 minute, okay, minus 1 minute. What will be the minus 1 minute? 4:00:20. So anything lesser than this, right? 4:01 minus 1 minute, right? Gives us 4 o'clock and 20 seconds. So anything older than this time will be removed, right? Will be removed. So in our case, these two will be removed. One, this was 4 o'clock. and 2, right? This was 4 o'clock, 10 seconds, right? It is lesser than, it is older than this time. So these timestamps will be removed, right? Now we'll see the second step. Once the first step is done of removing the older timestamps, we'll be seeing if it is greater than 3, if it is still greater than 3, right? So no, it is not greater than 3, right? It is, we have only one timestamp currently, right? So we'll add the new timestamp. We'll add the new timestamp, right? We'll add the new timestamp, for example, whatever it is, right? 410350, right? We'll add new timestamp, right, to the add-on. Okay. So this will be the steps, right? These will be the steps. Okay. So let's take another example again, right? Again, if the user is Michael, right? If the user is Michael, and at 5 o'clock, his first request had come, right? So let's say whatever is the timestamp, corresponding timestamp, let's consider this as a timestamp 000. Then another request had come, right? At 0.5 second, right? So uh, so according to this, right, it is we don't have any older timestamp greater than 1 minute. So we will and also it is yeah. So also the requests are less than 3, right? Only one request we have, less than 3. So we'll add this as well. 15.0, right? 0100, for example, right? And then another request comes, right? Another request comes, right? 50, 15 seconds. So again, we'll see the first step. Okay, we don't have older, right? It is within 1 minute only. Consider this current timestamp. Within 1 minute only, we have all the timestamps. Second step is less than. It is still less than 3 requests. We have 2 requests only. So we'll add this as well, right? 250. Now another request comes in, right? Another request comes in, right? Another request comes in. It comes at around 30 seconds, 5 or 30 seconds, right? Here we don't have older timestamps less than 1 minute, right? But in the second step, we have more than 3 number of requests here. Or adding this would make 4 number of requests, right? So we will reject this request. We will reject this request. We won't add. Okay, we won't add, right? So this is one step. We will reject this request. We won't add. Okay. Now, yes. So we have already seen, right, the 2 examples, right? So the first step is to remove the older timestamps, okay, which are greater than 1 minute, which are older than 1 minute, basically. And then we check after removing the timestamps, we check whether if it is after removing the timestamps, if it is still greater than 3, right? If it is still greater than 3, then we, what do we do? If it is, then we reject the request, or else we, if it is less than 3, then we add the new request, right, to the um, to this one, to the timestamps, and accept the request, right? So if you see, so let's say if we store this, right, in the map data structure in Redis cache, will come, what will be the storage? We'll see what should be the storage. But let's for consider, we'll store this structure, right, the map, user, and the value in the cache, in the Redis cache. So what will be the storage which will be required, right? For example, for storing user, we require 8 bytes, right? And each timestamp, for example, we require 4 bytes, right? 4 bytes. Okay. And the overhead of storing this set, okay, the overhead of storing this set, right? Let's say we require additional 20 bytes, right? Like maintaining all the pointers and all the stuff, right? So let's say set storing this set, right? Storing this set overhead, right? We require 20 additional bytes, right? And maintaining this hash table, right? This hash map or hash table, right? This complete. We require hash table overhead, right? Let's consider another 20 bytes we require, right? Another 20 bytes we require. So, for example, uh, uh, we have a system where it accepts 500 requests per hour, right? 500 requests per hour, right? So what will be the storage which will be required, right? First of all, 8 for a user, right? So what is the 500 requests per hour per user, right? If our system is accepting, then how much will be the storage required, right? So 8 bytes for the user, right? 4 bytes per timestamp, right? 4 bytes timestamp, right? One timestamp. So 500 requests. So we'll have to store 500 timestamps per user, right? Plus we have storing set overhead, right? Sorted set overhead plus 20 bytes, right? Plus 20 bytes into 500, right? So for user, we have to store 500 timestamps, 500 requests per timestamps. Plus we have to maintain 20 bytes this hash table overhead as well, right? Okay. So considering this 8 plus 4 into 500, right? 24 into 500 plus 20 bytes, it will give us around, 12 KB, right? It will give us around 12 KB. The storage will require 12 KB for per user. And if you want to store for 1 million, right? 1 million users, it will be 12 KB into 1 million, right? Which comes out around 12 GB. Okay. 12 GB. So, yes, so for storing uh, the timestamps, for tracking, for rate limiting for 1 million users will require 12 GB of storage. Okay. So definitely if for the as the number of users increase, the storage is also going to be increased. Okay. So what is the advantage, right? What is the advantage of this? Okay, of this algorithm? It is using sliding window mechanism, right? Sliding window mechanism. Okay, sliding window mechanism, which is, it is, what is the advantage? Basic main advantage: overcoming of fixed window, right? Fixed window con, right? That is, it is allowing, what is the advantage? It is allowing it is allowing the right number of requests, right? It is adhering to the rules, right? It is not allowing more number of requests, right? More number of requests. Okay, it is adhering to the rules. If we require, if we want 5 requests per minute to be accepted, right? Per minute to be accepted, then it makes sure that only 5 requests are allowed. Okay, this is the advantage, right, of a sliding window mechanism. What is a con? Con would be the memory footprint, right? The memory footprint. So more memory is required, right? In this to for this algorithm, right? So if it is 500 requests, right? So if it is like a million requests for a system, a million requests is to be accepted per second or per whatever it is, right? Per minute. Then this storage cost is going to increase. This storage cost definitely it is going to increase, right? So more memory is required for this algorithm. Okay, a lot of memory is required, memory footprint, right? A lot of memory is required, right, for this algorithm, right? So we have covered 2 algorithms till now. So the next algorithm is the sliding window, right? Sliding window with counter algorithm. Okay, so let's see uh, how is the sliding window. For example, we have this box of previous minute, right, and current minute. Okay, and what, and let's say we have this rolling window of, for example, I'll explain this. This is 30% and this is 70%. 30%. So this is the rolling window, rolling time window. Okay, window. Okay. So let's say how this works, right? It works on a bit of approximation. For example, if this was 4 o'clock, right? If this was this time 4 and this was 40100, this particular, right? 40100 and 40200. So in the previous minute, there were five requests, five requests, right? Five requests were accepted in the previous minute. And for example, our system allows seven requests per minute, right? Seven requests per minute. Now, till now, so for example, there were two requests till now in this window, right? Two requests had come, and on the um, 18th second of of this time, right? Of this time of 4 hour 1 minute, 18 second, another request had come. So how this works is, so at 18 second, uh, what is a percentage? What is a percentage of this current minute? Okay, it is 30%. 30%, right? That is, if it is 60-second window, what is the 30%? What is the 30% of 60-second? Right? It is 18 second, right? At 18 second, a request had come, right? So how this works is, number of requests, number of requests in current window, right? In current window plus number of requests in previous window, right? In previous window into overlapping percentage of rolling window, right? So number of requests in current window, how many requests are it is two requests plus one request at 18 second, right? At 18 second, that is three requests. Three requests had come. Now in the previous window there were five requests. In the previous window there were five requests, right? Now if we consider that, um, till now it is for the current window, right? For the current window it is 30%, right? At 18 second, at 18 second is 30%. So in the previous, to allow to check, right? For the previous window, how many, what will the percentage will consider? It will be 70%, right? Point 0.7, point 0.7, right? So it comes around this, according to this formula, 3 plus 5 into point 0.7, it comes around 6.5 requests, right? 6.5 requests. Okay. So if we can either round it down or up, right? So let's say if we round it down, right? Round it down, so it comes around six requests till now in this rolling window. In this rolling window, we have six requests in the current minute, in this rolling minute, in this rolling minute. So this new request, right? This new request will be, this new request which had come at for 18 second, right? At 18 second, it will be accepted, because till now it is making six requests per minute only, which is within our limit, which is within our limit, right? So what we do in this algorithm, whenever a new request comes, right? So according to um, the current window, what is the percentage, right? In terms of the current window, right? If it had come at 18 second, or from 401, from 401, right, to 40200, right? If it had come at 18 second, so we consider the percentage of the window till this time, right? Till this time, so it is 30%, right? So for this fixed window only, okay, what is the percentage? It is 30% now at 18 second, right? So what we'll do in the previous window, right? In the previous window, we'll take the remaining 70%, whatever is the percentage out of 100%, 70%, right? And we'll take the number of requests in the, right, which are done, which are accepted. So five requests, right? 5 into point 0.7, right? And this is, we'll consider in the previous rolling window, it was these many 5 into 0 zero 0.7 requests, right? Plus in the current 30%, there were 3 requests only. So in this way, we'll calculate the rolling time window, right? The rolling time window, how many requests are done? How many requests are done? So it was 6 requests, right? So I hope you have got this algorithm, right? So, uh, so what is the advantage? What is the advantage of this one? Advantage of this one is less memory footprint, right? Less memory footprint. Only thing is con is it works on bit of approximation, right? Approximation or not so strict look back time. Look back time. Not so strict look back time, right? Because we are considering bit approximation like 70% of the previous window, right? Or whatever it is, right? So, but we have observed, right, that like there's data from Cloudflare, right? Cloudflare, wherein out of 400 million requests, only point not 3 percentage of this 4 million requests were accepted, right? Which is, I think, should be it's tolerable, right? Point not 3 requests, additional requests were accepted. Okay, so these are the algorithms. In this, memory less memory will also be required. For example, user, right? User plus what will require here? Previous window timestamp. Okay, previous window timestamp, whatever it is, and the number of requests, right? And current window timestamp and the number of requests till now, right? Right, till now, number of requests till now. Okay, so less memory than the previous one, sliding window algorithm, right? Sliding window algorithm. So these are the algorithms which we have covered, right? Now, where will store this data? This user and this rate limiting the number of request data, right? If we store in some database, it is definitely going to be very slow because we'll have to do the disk access. As we know, in the database, we have to do disk access, right? In order to make it much faster, we'll have to store in cache. So we can store in cache like Redis cache, right? In the Redis cache, okay? In the Redis cache, and we have already seen what will it will store in the hash map or hash table structure, right? User and whatever the structure, right? In this way. And Redis, as we know, it will be memory lookup, right? Memory lookup. So definitely it is going to be faster. The latency, the rate limiting checks or rate limiting latency will be much slower, right? And where can we place this rate limiting? Where can we place this rate limiting? We can place this rate limiting in API gateway only. Okay, right? In API gateway, wherein the authentication and all that stuff is done. Okay, so we can place this rate limiting in API gateway. So this API gateway uh, uh, can query the Redis, right? For the data, for rate limiting data, right? If it is a client here, right? If it is a client, then so this is the high level flow diagram we can say. Okay, so API gateway will check, right, in the Redis what is whether to allow this new request or not. If yes, then we will forward the request to our application servers, right? App servers, right? Right, if no, then we will reject the request with error code 429. Okay, saying that um, uh, this request is throttled basically or rejected. Okay, with the proper reason, 429 proper reason, right? So this is, we can say, a high level diagram, not a bit clumsy, but I think it explains it well, right? That there will be client and API gateway will have the rate limiting logic. It will query this Redis, right? Redis cluster will have, right? Redis cluster will have, right? Right, so it will be much faster. Minimum latency, will adhere to the minimum latency. API gateway will decide whether to allow the new request or not. If not, then we'll send it with 429 error code. If yes, if it is the request is accepted, we'll add the timestamp accordingly and accept the request, and we'll forward the request to the application servers, right? So this is uh, system design for rate limiting. I hope you have understood it well. Please like the video and subscribe to my channel. It will motivate me to create such videos for you. Thank you so much.